Okay, morning class. This week we're going to be working on CAD Lab 6. This week's lab is a 3D modeling question. We are given the offset crank and asked to model it in 3D space and then dimension it. And then we'll have to develop 2D projection lines, delete all of our hidden lines and our overall lines. So we're just left with this outline here on the screen. And then we can change the line weight. So this lab is quite lengthy. The modeling process can take quite a while. So to cut down on time, I'm going to walk you through step by step. But once I'll repeat each command twice. If you miss it on those 2 attempts, then you're going to fall behind it because we have to keep moving on quite quickly. So if you're not able to see the screen, please move to a place where you can see the screen. And if you're not able to hear me, please just let me know. All right. So if you can, all open up your AutoCAD applications. Open up the handout for this week. Set up your workspace so that you're working in 3D modeling. Okay, we're not going to work in 3D basic this week. We're going to switch to 3D modeling and change your view to isometric. So turn on your workspaces, change it from drafting and annotation to 3D modeling. And then set your view to isometric, either clicking in the corner or going to view, unsaved view, and SW isometric. Okay, change your units to millimeters. Right. Okay, so this week's activity, we're looking at this offset crank. And if you remember from last week, I said that you have to break down everything into simple shapes if you can. So we have 2 shapes. First one here, second one here. We also have this slot and this shaft hole with the keyway. So what we'll do is we will break this down into these 4 components, then move them to their respective places, and then either union or subtract them to create the final solid shape. So to draw this first shape here, we're going to use something called the sweep tool. So last week we covered the revolution and the extrusion options for 3D modeling. This week we're going to go into sweeping. So for sweeping, you need 2 things. Like on the whiteboard right now, you need to define the surface area or the surface, and then you have to define the path. So the path runs perpendicular from the surface. So if you have a surface like this, your path can't run parallel to that surface. It would have to run perpendicular. Okay, so that's what we're going to try and achieve with this first top sort of S-shaped looking bit here. So what we'll do is we will draw this rectangular surface. We can select any one of these edges to be our path. So I'll select this outside edge here. So we have to find the dimensions of this path or these lines. Find the dimensions for this surface, and then we can use the sweep tool. All right, so looking at the drawing, what do you think would be the length of this rectangle? $24? No, not quite, not quite. So 24 is from center to center. 35, not quite. Yes. So you have your 24 plus the radius on this side and the radius on this side. So it'll be 24 plus 26, a total length of 50. 50, and our width here is just 16. So we're going to draw a rectangle. Remember, in our XY plane, you have to make sure our XY plane is flat. We're going to draw a rectangle, 50 by 16, and then we have to draw this path. So what do you think the distance from this top surface to this bottom surface is? What's the distance from this point to this point? Okay, we know that from center to bottom surface is 64, and from center to center line is 100, meaning this distance in between here and here is 100 minus 64, which would be 36. And then we know that from the center line to the outside edge, the radius is 13. So 36 plus 13, this total height here is 49. Okay. 49, this edge. What's the distance from this outside edge to this outside edge? 64, yes? From the outside edge to the inside edge, what are we looking at? Okay. 48. So we have a length here of 48. Okay, this radius 2 is also in our path. So we have a radius 10 fillet. And what's the distance from this surface to this point here? From this edge or this surface to this point here, where it connects to the round boss. Okay, we know that this width is 50 and this is 70. So these two don't line up at the center. It lines up somewhere on the circumference. So unless you want to do a lot of trick to try and find out where that point is, what we'll do is we'll assume that this part goes from here to the center. So we'll assume that this distance here is 64. Okay, so what we'll do is we'll model this one, then we'll model this one, then we'll union them and then subtract these. If you subtract this before you join this to this, you're gonna have like a square part cutting the bottom of your keyway. So try and union everything first and then subtract these two shapes. Right. So now in AutoCAD, right, we're working in 3D modeling, not 3D basic. It can be done in 3D basic too, but in 3D modeling, you have easy access to all of the tools that you'll need. Okay, once you've changed the UCS, let's just say, for example, you've changed it to this. And you want to go back to the original. Like you've drawn a shape and it's with this UCS and you click on the corner and now it kind of rotates awkwardly. What you could press is you could press this world UCS. What this does is it resets it back to the WCS. Remember last week I talked about the UCS and WCS, where WCS is built into the software and it doesn't change. UCS does. So if you click on this one here, world, it'll automatically set your UCS back to the world coordinate system. So if you click on that, you'll get back to this original. So if you get stuck anywhere along the way and your UCS looks a bit funky, you can just click on world and it'll go back to the original and you can try and move your UCS again. Right. So we're going to try and draw a rectangle, 50 by 16. You can select the rectangle tool. Make sure that your ortho mode is turned off. And you can sketch out your rectangle using the appropriate dimensions. Now, you'll notice that there's only one dimension that's highlighted in blue. That's at the moment, that is our, well, that's our length, technically, but we're going to set this one to 16. Once you set it to 16 and you press enter, you'll notice you can't change the other dimension. It feels like the other one is locked. So what you could do, or what you have to do, is you have to press tab button on your keyboard. Instead of pressing enter, press tab and you can switch to the other dimension. So again, rectangle tool, make sure your ortho mode is turned off. Start your corner. Okay, the first dimension you're going to enter will be your 16. Don't press enter, press tab. And set the other distance to 50. So now you have a rectangle. Okay. Next, we're going to try and define that path that we talked about. Okay, this 49 by 48 by 64. But you'll notice that we are drawing that. So currently our UCS is set up like this with X this way and Y this way. What we want to do is we want to flip that so that it's now Y going up and X going across. So we're going to have to move our UCS. So type in UCS, place it at that corner where we're trying to draw our path from. That's the origin. We set our X off to this side or this side, doesn't matter, this side or this side. And our Y to be vertical or, either up or down, doesn't really matter. If you came in a bit late, you might have to ask your friends to help you catch up to where we are currently. Haven't done much, just drawn a rectangle. repeat this once more. Righty, so what we're going to do is we're going to draw a rectangle that has dimensions 50 by 16. We're getting those dimensions from this top surface. So if you can figure it out, 24 plus 13 this side, plus 13 this side, we have a total distance of 50, and then the width 16. What we're going to try and do is we're going to try and draw this surface, then draw the path. So 49 by 48 by 64 with that radius 10 in here. And then we're going to use the tool called sweep. So it'll just create a constant S shape. All right. So in your applications, your AutoCAD, you're going to draw that rectangle first. So if you're in basic, okay, the rectangle tool is not obvious. If you switch it to modeling, it's here in one of the basic commands. So select the rectangle tool, specify the first corner anywhere, and you can draw out your rectangle. Okay, so right now the dimension that's highlighted in blue is the one that you can change. So if you type in 16 for that one, instead of pressing enter, if you hit tab on your keyboard, tab button, you switch to the other dimension. So you can set that one to 50 and press enter. Okay, so 50 by 16 rectangle. Then we're going to move our UCS to that corner here. So UCS, set the origin to the corner, put X either this side or this side, and your Y to be vertical, either up or down. All right, everybody here? Sam, up there? Alrighty. So now we're going to draw our path. Our path comes down, like I said, 49 down, 48 across, with the radius 10, and then 64 down. So selecting polyline, not normal line, polyline. We're going to go from that corner down a total of 49. Enter. And then 48 across and 64 down. So 49 down, 48 across, 64 down. Remote students, are you able to follow along? Okay, do we all have this? Sam? Yeah. Okay, now we're going to add our radius here. Radius 10. So we're going to use the fillet command. All right, so when you start your fillet, first you enter R, enter. So you can set your radius. So our radius for this one is 10. And then you select your lines. So again, fillet. You can come down here and click on radius, or you can type in R, enter. Set your radius. So radius is 10. Enter again, and select the two lines to create that fillet. So right now we have our path and we have our surface. Set, Sam? Alrighty. Now we're going to sweep this surface through this path. So if you come up here to where the extrude is, Click on that, you've got your four different tools. We'll select sweep. We'll then select the surface first because it says the objects to sweep. So the object to sweep is the surface. We'll click on that, press enter, and then we'll select the path. So you should have something like this on your screens. So again, select sweep, select the surface, press enter, and then select the path. Okay, everybody here? If you have drawn your path using normal lines, okay, if you've drawn it using normal lines, when you go to try and sweep, it'll only sweep to the first line. Okay, you won't be able to sweep it all the way through. So that's why we have to use polylines so that they're all joined and you can sweep all the way through. How's it, Sam? Alrighty. Okay. Now we're going to fillet our edges. If you look at our diagram, okay, we have filleted edges here. 1, 2. We have a third fillet edge here. 3. And these two have already been filleted because we've set our radius here as 10. So we have to apply 3 fillets, 1, 2, and 3. These two on the top have a radius of 13. This one here has a radius of 10. So what we're going to use is the fillet edge command. So type in fillet. Okay, you can do it with either both the fillet and the fillet edge command. The fillet might be a little bit more confusing than using the fillet edge. So what we'll do is we'll just use the fillet edge command. Now it says to select an edge. So I'll select this edge first and this edge because these two have the same radius. All right. Then I'll press enter. And then it says press enter to accept the fillet, but I want to change the fillet radius. So I'll click on radius and set my radius to 13. And then press enter. So again, fillet edge, select my 2 edges, 1, 2, press enter. Then I click on radius. I enter my radius now is 13 and then press enter. Fillet edge, select the 2 edges, 1, 2, press enter, click on radius and set my radius to 13, press enter, and then press enter again. Okay, the same thing will go for this edge here. This time the radius will be 10, not 13. So again, fillet edge, select the edge, click enter, click on the radius, set it to 10, and then press enter. And enter again. Again, fillet edge, select the edge, press enter. It says enter, please press enter to accept the fillet or set your radius. So I'll set my radius. I'll change it from 13 to 10, press enter, and then enter again. Remote students, are you able to follow along? Remote students? Yes. 64. Okay, if you hold down the shift button on your keyboard, as well as the scroll button on your mouse, you can rotate your object in 3D space. So holding down shift and the scroll button on your mouse, you can rotate your object to check whether or not you've done the correct command. Okay, you'll notice that like right now my UCS is not set in isometric. And if I try and go to the corner to select isometric, my object rotates. This is where you would use that world UCS that I was talking about. If you click on this and then you go to your isometric views, it'll reset back to the original. Okay, so that's the use of that world UCS. Okay, so we have drawn this gray shape. Sam, you drawn this up there? Okay, set. So now we're gonna draw the cylinder and then join these two shapes. So what we'll do is we will move our UCS to the center of this shape. So any line that's currently going in the y-axis, we're going to move our UCS to the center of that line and set it up so that we're drawing on the vertical plane. So I'll type in UCS, move it to any line that's running in the y-axis. So any of these lines, I'll choose this line at the back here and set up my UCS so that I'm drawing on the vertical plane. So I'll put X this side and Y vertical. All right. So again, UCS to the center of any line. I'll choose this one this time. X in this direction and Y vertical. Right. What we're going to do now is we're going to draw a guideline. So just a normal line that goes from the center of this line here, comes down a distance of 64, and then goes in a distance of 14. Why we're doing this is we are basically drawing a line from here that comes down a total of 64 and then goes in a total of 15 so that we're at the center of this cylinder. Okay, you'll notice that this distance is 50 and this one is 64. So the difference between them is 14, meaning that this surface is offset by a distance of 14 mm from this surface. So back in our drawing, just a normal line, not a polyline, a normal line from the center of this line coming down 64 and then in 14. Okay, so we have something like this. All right, so again, from the center down, total of 64, and then in a distance of 14, 14. Right, from this point here, we're going to draw a rectangle. So selecting the rectangle tool, we'll draw a rectangle that has the dimensions of 50 by 35. So again, rectangle, from this point, the dimensions will be 50 by 35. Okay, now we can delete our construction lines. So these two lines, we're just left with that rectangle. Now we're going to use the revolve function, but we're going to revolve around this axis. So selecting revolve, we'll select the rectangle, press enter, and select these 2 points on that rectangle, the bottom 2 points. We can now revolve it a full cylinder, so 360 degrees. We now have our cylinder and our S sort of a body. So again, we're drawing a rectangle. You can draw this using the rectangle tool or just polylines. 50 by 35. We delete our construction lines. Then selecting revolve, we select the surface, select that rectangle, press enter, and select the 2 corners on the bottom. We can then specify our angle as 360 and press enter. So right now we have 2 shapes. They aren't joined together yet. It's just 2 separate shapes. The next command would be to join them using the union tool. Okay, remote students, I'm going to end the session now and then continue using the same login information. Okay.